Okay, so this is the first of the buffering capacity type questions. The buffer itself was the one we did last day, on Tuesday. We ended up, just to remind you, we ended up with an HA concentration of 0.0087 moles per liter and an A minus concentration of 0.0613 moles per liter. Now, we are doing a calculation here that says you take 70 mils of the buffer. So we're not taking the whole 700 mils, we're taking an aliquot of 70 mils. So we want to figure out, we've got to go to moles here. We've got to figure out how many moles there would be in that aliquot of 0.07 liters. So we have to multiply our concentration by our volume to do that. So we have 0.000609 moles of HA, and we have 0.00429 moles of A minus. Okay, that's where we start the question. Now, it says we want to decrease the pH by 1.5 units by adding strong acid. So the pH started at pH 7, and it's going to be decreased by 1.5 units. That means we're going to pH 5.5. Okay, so we have to do all that math all over again, unfortunately. Everything we did last day, we've got to do it over again. So we go to Henderson-Hasselbalch, we put our new pH in, we put our same old pKa in, and we're just going to solve for these values. So this is negative 0.65 is equal to the log of A minus over HA. The ratio is 0.224 is A minus over HA. And we also know that the sum of A minus plus HA is still, and always will be, equal to 0.07 molar. So I am going to rearrange this. I'm going to say that 0.224 times HA is equal to A minus. Okay? I'm going to use that value and substitute into this equation. I'm going to go down here now. And that is going to say, I'm going to say 1.224 times HA is equal to 0.07 molar, which means that HA is now equal to, where is that? 0.0572 molar. By subtraction, that gives me an A minus of 0.0128 molar. Now I've got my concentrations, I need to know how many moles that is. So I'm going to multiply by volume again. Same volume. And I'm going to come up with values of 0.004004, if I can read my own handwriting, and 0.000896. Tell you one thing right now, this is where people make a lot of boo-boos, is they lose a zero somewhere. So check your math. Okay, so we have to go to moles. Previously, we had the number of moles of HA and the number of moles of A minus to start. And now we have a new number of moles. So if we find the difference, the absolute value, we have 0.004004 minus our starting number of moles. We come up with 0.003395 moles. That's the difference. We will also calculate the difference in A minus. I'll let you do that on your own. It's the difference between 0.00429 moles to start and 0.000896 moles at the end. You get the same value. That's how many moles of acid we must have added to combine with the A minuses to make new HAs. Okay? And how many mils of acid this was? We divide by the concentration of acid that we added. And that comes out to 0.00485 liters or 4.85 milliliters. So the key here is what happened when we added H plus to our buffer is that A minuses got together with the H pluses that we added and made HAs. So our number of A minuses became depleted and our number of HAs increased. So we shifted the equilibrium from one place to another, and it took 4.85 milliliters of acid to do that.